Hello everyone. Today we're diving into a remarkable operation that unfolded in the early hours of May 24, 2025 in occupied Zaporizhzhia Oblast. Ukrainian forces executed a precision drone strike on a critical Russian fuel train, disrupting a key logistics lifeline. This meticulously planned mission showcases advanced technology, strategic coordination, and the courage of those involved. Let's break down how this operation unfolded, the technology behind it, and its impact on the ongoing conflict. At 2:43 a.m., 3 Ukrainian strike drones pierced the darkness over Zaporizhzhia Oblast, targeting a Russian fuel train along the Vern-Tokmak-Malakhansk railway line. This 8-car train carried approximately 560 tons of diesel fuel, enough to sustain 2 Russian battalions for a week. The railway is a critical artery for Russian logistics, funneling supplies to frontline units. Destroying this train would deal a significant blow to Russia's ability to maintain its operations in the region. The mission involved 5 drones working in tandem, a DJI Mavic 3 for reconnaissance, 3 Ukrainian-built FPV quadcopters for the attack, and a reserve Mavic 3 for backup. The operation was supported by a network of partisan spotters and a command center 30 kilometers away, highlighting the blend of technology and human intelligence that made this strike possible. The drones used in this mission are far from off-the-shelf models. The DJI Mavic 3 reconnaissance drone, modified in Ukraine, is equipped with a Hasselblad L2 D20C camera, boasting a 20-megapixel sensor, and up to 28x hybrid zoom with experimental firmware reportedly extending digital zoom to 56x. Some units feature FLIR boson thermal cores, enabling heat detection at night. Cruising at 68 kilometers per hour, these drones can operate for 46 minutes at altitudes up to 6,000 meters, making them ideal for long-range surveillance. The Ukrainian-built FPV attack quadcopters are designed for one-way strike missions. Powered by 7-inch propellers and 2,807 class brushless motors, each delivering 2.5 kilograms of thrust, these drones can reach speeds over 140 kilometers per hour during terminal dives. Tuned with F7 flight controllers and custom Betaflight firmware, they maintain stability even at high speeds, making them highly effective for low-cost precision strikes. Each quadcopter carries a 2.6 kilogram-shaped charge warhead with a dual-stage detonation system. These warheads, made of hardened steel and tungsten alloy, can penetrate 22 millimeters of steel, more than enough to breach the 10-15 millimeter walls of Russian fuel tank cars. The explosive jet travels at over 30,000 feet per second, igniting fuel at temperatures exceeding 2,500 degrees Celsius. The operation's success hinged on precise intelligence and timing. Ukrainian partisans, risking their lives under occupation, tracked the fuel train for 72 hours using smartphones. They identified its refueling schedule, speed, and a critical 15-minute window when it was furthest from Russian air defenses. This intelligence allowed operators to plan the strike with pinpoint accuracy, ensuring maximum impact with minimal risk. From a secure command center, operators monitored thermal feeds from the Mavic 3, which detected temperature differences as small as 0.05 degrees Celsius at ranges up to 200 meters. The drone's firmware, modified to evade Russian aeroscope detection systems, ensured it remained undetected. The thermal signature of the train's diesel locomotive stood out against the cool landscape, simplifying target identification. Encrypted communications relayed this data to the strike team, setting the stage for the attack. At 2:44 a.m., the first FPV quadcopter began its attack, guided by a combination of encrypted GPS and terminal optical guidance. In the final 15 seconds, the drone switched to optical guidance, using image recognition algorithms to lock onto the train. Hitting a moving target traveling 11 meters per second required precise calculations. The drone's fixed-mount camera, with digital stabilization, provided a clear video feed to the operator's goggles, maintaining visual contact during the high-speed dive. Suddenly, a Russian LER-3 electronic warfare system, mounted on a Kamaz truck 3 kilometers away, detected the drone's signals. Capable of jamming GPS and control frequencies across a 30-kilometer radius, the LER-3 began broadband jamming, flooding multiple frequency bands with noise. When this failed, it switched to spot jamming on the 2.4 GHz band used by commercial drones. The Ukrainian operator reported connectivity warnings as the control interface faltered. However, the Ukrainian drones were prepared for this. Both the Mavic 3 and attack quadcopters used frequency-hopping spread-spectrum technology, switching frequencies up to 1,200 times per second across 3 bands. This made it nearly impossible for the Russian jammers to lock on. The Mavic 3's AI-enhanced sensors automatically scanned for alternative frequencies, maintaining target tracking. The attack drone switched to an L-band backup channel, distributing its signal across multiple frequencies to evade jamming. The Russians also attempted GPS spoofing, sending false satellite signals to mislead the drone, but the drone's inertial measurement unit, IMU, equipped with accelerometers and gyroscopes, detected inconsistencies and switched to inertial navigation. This backup system, immune to jamming, ensured the drone stayed on course by tracking velocity and direction changes. At 2 hours 44 minutes and 30 seconds AM, the first strike drone hit the third fuel tank car. The shaped charge detonated, its tungsten penetrator piercing the 12mm steel wall. The secondary incendiary charge ignited the diesel fuel, creating an explosion exceeding 2,500 degrees Celsius. The blast vaporized hundreds of gallons of fuel, rupturing the tank and sending a heat bloom across the thermal feed. Secondary explosions followed as the fire spread to adjacent cars, facilitated by the train's interconnected ventilation systems. With the train now stationary after the engineer applied emergency brakes, the second and third drones struck. The second targeted the sixth car, using smoke and flames as concealment. Its thermal imaging system locked onto the cooler metal signature of the undamaged tanker, compensating for heat distortion. The third drone hit the eighth car, triggering another massive fireball. Together, the strikes ignited 560 tons of fuel, creating an inferno visible from kilometers away. The fire generated convection currents, pulling air into its base and sending a column of smoke and flame 200 meters into the sky. The railway was rendered inoperable, with warped tracks, burned wooden ties, and debris littering the area. Russian repair crews will need weeks to restore the line, assuming they can work without further Ukrainian strikes. This operation showcases Ukraine's ability to disrupt Russian logistics with low-cost, high-impact technology. The loss of 560 tons of fuel weakens Russian frontline units, forcing them to reroute supplies or rely on less efficient methods. The destroyed railway line, a critical supply route, further strains Russia's logistical network, potentially delaying operations in Zaporizhzhia Oblast. The mission also highlights the role of partisans in modern warfare. Ordinary civilians using basic smartphones provided the intelligence that made this strike possible. Their courage under occupation underscores the human element behind Ukraine's technological edge. The Ukrainian drone's ability to counter Russian electronic warfare is a game-changer. Frequency-hopping technology, inertial navigation, and AI-enhanced sensors allowed the drones to operate in a heavily contested electromagnetic environment. The combination of GPS, optical guidance, and inertial systems ensured precision even under intense jamming. This adaptability makes Ukrainian drones a formidable tool against Russia's more conventional defenses. The Mavic 3's real-time surveillance, paired with the attack drone's precision, demonstrates a dual-platform approach that maximizes effectiveness. The reconnaissance drone's ability to cut through smoke and flames with thermal imaging ensured continuous target tracking, while the attack drone's autonomous capabilities allowed them to complete their mission despite disruptions. This strike is more than a tactical victory. It's a statement of Ukraine's growing capability in asymmetric warfare. By targeting critical infrastructure with affordable drones, Ukraine levels the playing field against a larger adversary. The operation disrupts Russia's supply chain, forces a reallocation of resources, and exposes vulnerabilities in its air defenses. The involvement of partisans also signals strong local resistance in occupied territories. Their intelligence-gathering efforts, combined with Ukraine's technological prowess, create a potent combination that could inspire similar operations in other regions. This operation in Zaporizhzhia Oblast illustrates the power of precision, technology, and human resilience in modern warfare. As Ukraine continues to innovate and adapt, strikes like this could shift the conflict's momentum. We'll keep tracking these developments to bring you the latest insights. Thank you for joining us, and stay informed.